This is a high pressure pump package used for misting applications. We've got a control panel on the left and a pump package on the right. And this, so you can see the pump. I'm using a laser pointer. We've got the pump and motor down here. And it is running it right now. It's producing some mist. It's running at about 10 hertz frequency, and it's putting out about 200 psi, a light pressure. And you can see the mist here. It's coming out. And that's 4 nozzles, very small orifice nozzles at 0.08 millimeter nozzles. And this pump has the capability of 0.03 gallons per minute GPM. There's the pump itself. So that's a capacity. It can run at 1,000 psi at 0.3 GPM, but we're running at a much lower pressure. You can regulate the pressure through this regulator right here. That can set and adjust the pressure output. And the motor itself is a 3rd horsepower 3-phase motor. So with the 3-phase motor, you have the ability to vary the frequency, to vary the output capacity of the pump. Now that 3-phase motor is being driven by this variable frequency drive in the control panel on the left here. This is an Allen Bradley half horsepower 3-phase variable frequency drive, and it is supplying this motor through this cable assembly. You can see that there's a cable coming out here, a mate and lock connector with a 12-foot connector, and it goes onto this other mate and lock connector over here into the motor itself. Now the control panel, or the whole pump assembly on its own, is gets power by just 115 volts AC. So it's 120 volts. So it's just a standard plug that is powering this whole assembly. There is a disconnect way over on the left here. There it is. I think you can see it's just a standard disconnect. It does have a lockout assembly in it, but it's just a single-phase breaker or disconnect switch that supplies power to this assembly. So even though there's just 115 volts coming into it, the variable frequency drive, the VFD, is taking 120 volts coming in through this breaker right here and actually converting it to 208 volt 3-phase going out. And you can see that there's 3 wires down here going out to the 3-phase motor. Now this control assembly over on the left here does, quite a few different things, but overall it does just a couple things when you look at it, and that is that this microcontroller here starts and stops the machine and actually drives the solenoids that you see, solenoid 1, 2, 3, 4, 5, 6, and we've got a couple spares down here. These 6 solenoids here turns them on and off depending on the demand, and then the water actually goes out the hoses and supplies it to the misting heads. The other thing that's going on here is that this microcontroller is actually monitoring a lot of this package. It's monitoring the pressure, output pressure through a pressure transmitter. It's monitoring the incoming pressure over here on the right to make sure that there is a water supply coming into it. It actually has a temperature monitor up here in the upper right hand corner. Monitors the temperature of the pump panel just to know whether it is in some extreme environments and to know what the temperature is inside. And then it also has a water sensor down here at the bottom that actually senses if there's a major leak within the control panel, and it will shut it down. These pressure transducers will shut down the machine also. If the pressure drops below 10 psi on the incoming water supply lines through this transducer, it will shut down the package. If the discharge pressure drops below 130 psi, is where I've got it set right now, it will shut down the pump package. And again, if there is water in the assembly, it will shut down the pump package. That water sensor does have a 30-second time delay on it, so it's got to have water in the panel for at least 30 seconds, and then it will shut down the pump package. There is one other control that I haven't put in yet. I do need the proper fitting to put it in, but over here in the lower right-hand corner is a flow meter itself. And that is going to go in the line right above it there, right just below the incoming pressure sensor. There is a piece of tube there. That's where that flow meter is going to go. It'll monitor the amount of water that's coming into the unit and be able to log how much water or how much capacity that the unit is actually putting out. So all this sensors are actually fed back to this microcontroller again. This is an Allen Bradley 1100 series microcontroller, and actually on the bottom, all the red wires down there in the bottom are the solenoid control wires going out, and the yellow wires up on top here are actually some of these sensors coming in. And then there's two expansion modules over here that actually have some sensors coming in also. So if you look at this control panel as a whole, we've got a input section up here, and then we've got a control section, and then we've got an output section. Now this device down here, these two small devices, this is actually a timer. It's a 7x24 timer, or 24/7 days a week timer, where you can cycle this unit on and off through that timer. So that timer is right into the start-stop circuitry, and if you wanted to set it to quit at midnight and start back up at 6 a.m., you can use that timer right there. You can also use this microcontroller to do that, but then you need to have an interface, which I'll demonstrate after a while, an interface for that. But within this device, there are kind of some there's some override features of it, or some manual control features, and one of them is this timer right here, and the other two are these toggle switches right here. There's two toggle switches. You can see that one is on, that one right there, and that one is off, and those are override toggle switches, which will when you toggle one on, it actually brings on 3 of the solenoids for output. You toggle the other one on, it'll bring on 3 of the other solenoids for output. So combined with that and this timer, those are kind of a manual control operation. Within the microcontroller itself, we can utilize some automatic control operation with a PC interface, which we'll demonstrate in a little while here. Now, we'll go over just the input assembly a little bit here. Power wire comes in here over at the left. Up on top here, that's actually a surge suppression unit, transient TVSS, transient voltage surge suppression unit, to eliminate any spikes that might come into the unit, a little bit of a protection. This is a control transformer, 120 volts in to 24 volts AC out. That actually powers, any of these controller actually powers the solenoids. The solenoids are 24 volts AC. We've got a couple of power terminal blocks here, and we've got a couple of circuit breakers. One of them is the main input circuit breaker on the left, and the other one is the transformer circuit breaker. And then over here we actually have a third circuit breaker, which is the circuit breaker going into the variable frequency drive. Next here is a DC power supply. This is 24 volts DC, that actually is the power that powers this microcontroller here and its other I/O modules. So these are two separate units. We've got a control panel and we've got a pump panel, pump package. There are two cable assemblies. I showed one to you a little earlier that connect the two together. So they are shipped separately. The cables are inside each one of the control panels. And there is one for the variable frequency drive coming out of the VFD and then it actually goes into the variable frequency drive into the motor. The other one is the control cable. That's down here on the lower left, down over there, just below the disconnect, and actually its incoming connection is right there, and that goes over to the pump package over on the far right. There is a connection right there. So that's a 12-foot cable. Both of them are 12-foot cables that interconnect the two pumps. So you can see the one here over on the left actually takes from these this block here, this terminal block here, all the wires. There's actually 28 wires here off these terminal blocks. Some of them are ganged together a little bit for grounding and for neutrals. But all those wires go into that cable assembly, 12-foot over here. And then you can't see it, but there's another terminal block in the back that actually feeds power to the solenoid valves, and then it feeds power to each one of the controllers or the transmitters that monitor the unit. One thing I didn't point out, each unit does have a gauge on it. So we've got solenoid 1, 2, and 3 open right now, but we only have water coming out of number 2. But you can see that right now it's up there just about 200 psi that it's running at. And then we've got a main gauge also up here. So each one has its own gauge, and then we have a main gauge. So if you wanted to run this thing, say it was shipped to you, you've got the two panels, you've got the two control cables. So you would set them up. You could set them up, and you could take the two control cables, one power cable from the VFD and one control cable. You could plug those two in to each other, plug in an incoming water supply over here at the left or at the right, the black tube coming in, and then put in an output over here on the right also, the white tube going out to the nozzles. Put that on there. Flip, turn on the power, turn on these two breakers here. Actually 3 breakers, these two here, this one here. Flip those on. Let it warm up a little bit, and what I mean by that is let the processor start up. And then all you have to do is toggle one of these switches, and the system will start up and start putting out pressure. This timer here actually has to be in an on mode. If you push, there's a button down here at the bottom. You can push it on to off, but right now it's set to run 20 hours of the day from 2 in the morning. That's when it stops. It starts up at 6 in the morning again and runs for 20 hours straight. And so there is a battery backup in that clock there, and it is set to run all the time. So it is set right now to, even if it is shipped and you plugged it in and started it up, if it was during normal working hours, it would start up. So again, plug in the two cable assemblies, plug in the power, provide input and output water, flip the dip switch for the solenoid 1 through 3 or 3 through 6, and the system will start up and start running. Oh, and by the way, turn on the breakers. That's the other thing.